topographical maps which were available at that time were made by the American Air Force. They were mainly done during the Second World War and a little afterwards, but they hadn't got the necessary ground control, which means that the printed maps they issued were with very big differences in actual position, up to 50 kilometers. So that was absolutely impossible for us to work with.
Welcome to Polar Podcasts, where you'll hear stories from geologists who've spent their careers, their lives, exploring and studying the remarkable and remote geology of Greenland. Why did they become fascinated with Greenland? What were the problems and the discoveries that drove them? And what was it like working in these remote places, where few people venture, even now? I'm Julie Hollis. In this episode, we hear more from Niels Henriksen, Emeritus Senior Scientist at the Geological Survey of Denmark and Greenland, about geological mapping in the most inaccessible part of Greenland, North Greenland, in the mid to late 1970s.
We had no information about North Greenland, so we had to start mapping in scale 1 to 100,000 in fieldwork, and with the aim of producing 1 to 500,000 maps from North Greenland. North Greenland is huge. Its east-west is about 1,100 kilometers, and north-south it's about 200 kilometers. Just like in North-East Greenland, you have to realize that it was an area where you had absolutely no infrastructure. You had to organize everything yourself, and geology of North Greenland is completely different from everything else GDU had worked with previously. So we have to reorganize ourselves both logistically and geologically again. And again, I was fortunate enough to be asked to start this and first of all reorganize, come up with a plan of how to work there. This started with me as a metamorphic petrologist who had practical experience in basement geology.
That is, the igneous and metamorphic rocks.
It started with that I was working together with a geologist we had employed in GGU at that time, preparing ourselves for working with sediments of lower Paleozoic age.
That is, sedimentary rocks formed between about 540 and 420 million years ago.
This geologist, John Peel, who was with us for many years, became professor in Uppsala, where he has been for many years. He had his first field season in 1975. And at that time, he was completely inexperienced in Greenland geology. He was also inexperienced in living in a tent under field conditions. So he and I and 2 assistants worked together there. We took a season together simply to learn how to work with sedimentary units, and for him to simply to learn a bit from me about what field work was like and how it was to work with pure maps. Yeah. So that was the season 1975. We spent a season there in the area called Washington Land, which we flew into Thule Air Base. We had a Canadian twin otter who flew us 200 kilometers to the north into Washington Land. And there we stayed for the full season. We had lots of problems beginning because the twin otter sank in and it took us a full 24 hours to dig it out. I learned a lot about measuring sections up together with John Peel, and we sat for hours hammering small stones to find fossils. And we worked with units where Cambrian, Ordovician, and some up into the lower part of the Silurian.
Again, that is sedimentary rocks formed between about 540 and 420 million years ago.
And I learned about measuring sections. I made a detailed list of all the sections we made. And John Peel was preparing himself for taking over the leadership of working with all the paleontological and all the stratigraphical work we had to work with in North Greenland later on.
That is, working with fossils and understanding the relative layering of the sedimentary rocks and their relationships in geological time.
That was 1975, where we did mapping, but not a lot, because we had no helicopters. We had to walk around, but we got a lot of primary information for that season, and then we got an impression of how to organize the work in North Greenland. John Peel continued to work in the region in 1976, and I shifted in the season 1977 to work in the easternmost part of North Greenland. There I simply flew around together with the military, serious people. They were coming around, putting out small depots for their work where they had their sledge patrol areas and roofs. They had to get provisions out in a small hut. I got the opportunity to go around with them, so I got an impression of the area and how we could work with that in a geological sense. I also stayed a period there with the archaeologist Eigil Knut, who was a well-known Danish polar explorer, one of the old hands. He nearly completely alone did work with archaeological problems, studying movements of Eskimos from western part of Canada into the northern part of North Greenland, down the east coast. I spent time with him there. After this first reconnaissance season for myself in 1977 and John Peel's work, which continued from 1975, we were able simply to come up with an evaluation how we could tackle the geological mapping of the area. We had to do, first of all, topographical mapping, which was done here in GGU as photogrammetric work, in close coordination with the Geodetical Institute people. They were cooperating with us and were measuring all the ground control points which was necessary for doing the aerial photographical topographical mapping. And after that, we simply made an evaluation of how much time we needed and what kind of geologists we should have. And then John Peel, who got lots of contacts, got a group of paleontologists and stratigraphers who was working in the area. We had about the same size of organization as we had previously, which meant that we had about 10, 12, 15 two-man groups out every summer. Summers there about 1.5 months. Logistically, we did it the same way as I've talked about just before. We came in with the whole group with the C-130, the big military aircraft that could take a payload of about 10 tons into Station North. And then we flew in with all equipment, all personnel. Fuel was flown in 2 months earlier than when we started our own field work, if there was frozen ground, so it was hard enough to have the C-130 landing there. It can't be done when you have normal summer temperatures, which is about freezing point, because then the ground is becoming soft. Therefore, we had to send out ground personnel, a few of our equipment people, who were staying there in the early to middle part of May. We flew in all the fuel at that time, many trips from Thule with C-130 load. So we used more than 100,000 liters of fuel. We flew in about 10 times from Thule, landing on this natural landing strip at a place called Kap Molke. We had all the fuel stored in bladder tanks, rubber tanks, which simply lay on the ground. When we had prepared fuel for the working season, then the geologists and our support group, which was helicopters and Twin Otter, came in late June, early July. But at that time it was from year to year varying a lot how much snow you had. In some years we had very little snow, and in other years we were completely drowned in snow in the beginning. So it's difficult to say on beforehand when is the best time to start. But we had to start anyway in the, say, early part of July. Then we could stay in the area until about the 20th to 25th of August. At that time, the general day temperature went below freezing point. Then every time you had a little precipitation, it stayed there as snow, and then you can't see what you want to see. Then you had to go home. So we had in general something like 6 to 7 weeks of fieldwork. At that time, the helicopters came in with the C-130s also. It was one of the newer type with the lifting capacity about 400 to 500 kilos, then with the average flying almost 200 kilometers an hour. So it was very efficient. Jet Rangers was the term. Later on came more modern times. But anyway, that was a big difference from where we started with the piston engines, early helicopters. And then you had the Twin Otter. The Twin Otter was used to place out depots, flying around with small geologist groups, putting out fuel depots and other depots for the field people. And then we used it a lot for taking photographs aerial photographs. They flew along the big fjords and all along the valleys, so you had fantastic coverage of oblique photos taken from the Twin Otter. Our photographer Jakob Lautrup and I did a lot of the work. We simply planned the flying. We had the Twin Otter for ourselves, and we would organize this as it suited us. You have to do it only when you have possibility to fly without having shadows or clouds or whatever. So some areas you have to fly in the night time and some in the daytime. We could easily organize that because you have 24 hours daylight. First in middle August, the sun starts to go below the horizon. So we had a good possibility to do a lot of observations from the photos, from the flights and from the helicopters. So we have a fantastic amount of photos from the whole region. When we started in North Greenland, we from the very beginning realized that it was necessary for us to establish our own topographical base for the work. The topographical maps which were available at that time were made by the American Air Force, and they were mainly done during the Second World War and a little afterwards. But at that time, when they compiled their maps from photos, they were in a situation where they hadn't got the necessary ground control, which means that the published maps, printed maps they issued at that time were with very big differences in actual position, up to 50 kilometers of displacement. So that was absolutely impossible for us to work with, especially if you had to do it photogrammetrically as we wanted. Therefore, it was from the beginning decided that we had to do the topographical mapping ourselves. At our photo lab in the GGU, the Geodetical Institute didn't have capacity to do it, so they delivered all the ground control points for us. That was at an early stage GPS measurements. They flew around one season and did all the observations which were necessary for them, making ground control points with a difference of about 50 kilometers. And all the ground control in between there was made by aerial triangulation, which could be done in the lab. So when we worked there the first 2 years, we more or less had a full-time man occupying with doing topographical maps. At the same time, it was combined with the geologists who worked there. They were in the instrument when they have done the topography. They had time doing whatever they could with geological interpretation from the photogrammetrical instruments. This was very fortunate because people with a field geological experience would sit and do interpretation in the instrument, and at the same time we had general work done by one of the geologists who was employed by GGU as a full-time photogrammetrical geologist working as a photogeologist. In preparation for our work, he did a full geological interpretation of the whole area, so the geologists working in the field were simply given a photogrammetrical interpretation of the geology before they went into the field. That made it very much easier because the geologists mainly had to concentrate on establishing the stratigraphy.
I'm Julie Hollis, and you've been listening to Polar Podcasts. In the next episode, we hear more from Emeritus Professor Kent Brooks about a very close call in a helicopter accident while flying in East Greenland in the 1970s.